Hello and welcome back to a new Fluke Friday. I think it is episode 18 and today I have something, well, it's not vintage, it's also not super new, but they are kind of rare. And that is the Fluke Graphical Multimeter, the 867, and I also have an 867B. The difference is I think only the display between the two of them. And they are not that easy to find. They even kind of rare. Well, if you have a big wallet, I'm sure you can still find them on eBay, but if you want to be a little bit economic, then it's kind of difficult. So I found the non-B, I found also on eBay, but from the US. So they were sold as working, but in the end a lot of functions did not work, but I will show you later. And I found one in France. This one comes from Paris, and even the address is still in the back from the dealer. And this is the B, and the B has an improved display. It does look a lot better. Size-wise, they are huge because this is a normal 87. Let's have a closer look. Little disclaimer, this video is not sponsored by Fluke. These items are not original, but I made this for the purpose of this video because I'm a fan and of course because of the copyright. It will not be for sale. Here we have both of them. We have the 867, the normal one. It has a normal LCD, but it does have sort of an orange backlight. And this is the new improved one, the 867B. It looks now very black, but the display is actually white with a bright backlight. Well, we can have a look around first. Also, it can communicate again with the Fluke infrared, and then I think you use the Fluke Form or the Fluke View software. It has a big battery. We can take this out. Well, let me just get the other one here. It is a big battery compartment and it holds very special batteries. And these of course cost a fortune if you want to buy an original. It is the BP7217, but there are also of course from China fake ones. But there is another nice option in this battery holder. That's kind of smart. You can just put your cells also. So that's what I'm doing. I have here a very high capacity AA's and you just put it here. And then you can operate it with cheap batteries. And the thing is, it doesn't charge like this, but I read already in a forum somewhere that you need to, there are two contacts in the middle somewhere, that if you connect those two contacts here, I think these two, then it will just charge. Okay, so we have the off button, we have the AC voltage, and you can see this display is, it's okay. Maybe if I switch off, yeah. We are now automatically in the millivolt AC setting. I'm not sure if it does switch to higher. I didn't test that. Here we have also sort of a scope function. There is a peak hold, a relative, RMS or average. You can do dB measurements, but now it's fully in automatic. So this function works, and I like this little scope in the back. Here we have the DC voltage. The DC voltage does not work. You can see the display is still lighted and also the grid is there. But somehow this setting does not work. Then we have the millivolt. That does work. Millivolt setting, frequency. Again the little scope, peak hold, DC and AC combined. dB measurement, it's now in high impedance, but you can switch that on and off. And we have brightness, contrast, look at that, now it's a lot better. So the display doesn't show any lines, so the display is good. we have ohms measurements. It does work. That's cool. Even with a sort of a bar chart, but then they try to do analog measurements. Okay. We have diode measurements. We have milliamps, microamps. It even tells you where you need to put the probes. Then we have AC measurements and higher currents. And so, except for this function, most of the function works. Then we have the setup menu. And here we also have a problem, so I cannot change the settings. Also, again, the grid is there, but that's all it is. Then there is a component test. And look at this. I'm not sure if you have a curve trace here, but it looks kind of cool. You can select different frequencies. And then there is a logic. And there you can also do stuff. I didn't read the manual, of course. This 87 looks so small compared to these meters. So I already opened a normal 867. And well, a lot of screws, but then in the end you can open it. And then I found the top of the switch. So there are multiple switch layers, because in the top there is one, but also from the bottom up there is one. And hopefully it is just dirty contacts, or we have to look a lot further. I will open both, so then we can compare them even to see if there are more differences than only the display. Well, there are just 6 screws here. And if you undo that, then you come here, then we have a few screws here that holds the protection. Then you can open it, and here there is a switch, and it is done with this little wheel here. It's just clicked on. So when you take that off, we can go deeper. And this looks a little bit dirty, so hopefully that is just it. But it could be a lot more, of course. There are a lot of components around here, so if one of these components are faulty, it doesn't see what you switched. And once removed that, there is the power plug that is very, very short right here. So when you take the board out, you immediately will disconnect the power, and it will be a challenge to put that back in. I'm not sure if because it is so short, yeah, well, we see when that comes, the display connector, and then we have that. But here also another switch. It's the same switch, but multiple contacts, so there can also be a problem here. The relay here, yeah. Let's just see. Let's open the other one. We're going back at that switch. If I zoom here, this looks quite okay. This look almost like it's silver. It's a little bit oxidated, but it just decolored a bit. I think this will be fine, but we can clean that for sure. But if I look at the other side, it seems that they put, I don't know, they try to put contact cleaner, but it just looks very greasy to me. And I wonder if this even makes contact. This looks terrible. So that's what I mean with cleaning. And I really hope it's this. Let's get the other one. Well, the foil was still on this display, and that's why, even if it's an older version, look at this, the screen is like new. So that is great. But we haven't seen it switched on. And this one didn't have its protection anymore, so that is all scratchy. But we have seen with all the other meters before that is easy to polish. So let's go open this one. So we try to open it carefully. Yeah. Now we even have a spare fuse here. Oh, it looks still the same. Let's get some protection. Okay, that is also the same. I think there are still screws here. Yes, there are. There is one here on the top. One here in the top. And there is one here. Yeah, and here also this switch area looks again very dirty. The same, this area looks very dirty, so now I need to try to take this one off. And I just do that by pushing something very thin, because it is just locked in it. And then I need to try to push it open, and then I can lift it. Okay, that took a lot more effort, but it is loose. Then we should be able to lift it. The top is loose, the bottom is not, but I think it is kind of stuck here in the probe connection, so we should be able to lift this, I think. Yeah. Yes, there it goes. And then we have one hurdle, and that is again that power connection that is stuck in the bottom. And I have no idea how you can do this properly. I can just pull it now and then it's loose. But how do I get it connected back? Yeah, there it is. That was the power connector. And it is just so short. I hope I can get it back. That will be a challenge. So, display. The switch looked improved already. Let's put them side by side. The mystery with the power plug. It is solved. You can just slide it out. So you connect this to the board, and then when you slide the board in, you just slide the power plug in. But it looked stuck like this, but then you can just move it out. Perfect. Well, the main boards look very, very similar. This one, they used here a different plastic on the switch, but it still looks the same. It's just another material. Well, I must say they look very, very similar. Maybe a software version here on the top is a little bit different. Let's have a look at that. This is a version 1.3 and this is 1.4. Okay, let me just get my microscope. Here, 94, it's version 1.3. 1.3, 94. We have here some letters on the board. So this is the first one. The 1.4, also 94. What is the revision here? Doesn't say. This one, 94 FA. 94 FA. Epson chip. Same, different brand, but the same. Same. Have a look at the switch area. Yeah, maybe we can clean a little bit here. Make sure the contacts are good. Turn it around. Yeah, it looks also kind of dirty. This newer switch looks better. But still, I think we can try to do some cleaning and maybe we can bend the contacts so that we are sure that they make contact. I do see a little modification that they made here to the connector. And that could be because there is a little switch inside these. And sometimes they just break. I can't see the track, but I know there is a dual layer because here in the light we can see. You can see that little trace there. Well, they look a lot better from close by. So let's see if they work better than they did. So what if we switch it on? Nothing. 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 And the ohms works. Ooh, this display is really not that good. Okay, that function works, but this already did, I think. There are some nice tricks, by the way. You have here this is the normal combo mode, but you can also say I just want a meter, or I want a scope, and we can see that a lot better in the other display. Trend graphs, these are pretty cool meters when they work. Yeah, this logic mode is actually the component mode. That is weird. And you can power it with a power adapter, but then you need a very, very special power plug. This one is even more weird than from the scope meters. Let's get the other one. I managed to clean it pretty good. The display also is looking a lot better. And let's see. Voltage AC. Same here. Can I do more light? Yeah, even more light. Perfect. And display mode, we can do the meter. We can do the scope view. And it's pretty detailed everywhere. Trend graph. Or the combo. Okay, so the millivolt works, the AC volts. The DC volts, no. I did have this working for 5 seconds, but now it doesn't work anymore. The millivolts, that is then up to, I think, 3 volts. Same here, we can do the meter or the scope view. Trend graph or mixed ohms, still working. Diodes and capacitance, I think. Yeah, I can switch here. I like this, that you can then you know where you need to put your plugs, but of course you need to wait for that. I think you can change that in the B version. You can change that if you want to see that or not. But I think in the first version you cannot do that. Yeah, this is the component test and the logic, so this one actually works best. But still weird that these settings are missing. Well, let's do AC. I have my DMM check plus. On AC, power on. Do we have 5 volts RMS? Yes, we have 100 Hz. That was pretty cool. Yes, we are in RMS. We see the correct value, we see the frequency. And if we do meter only, we have the meter. What if we do view? Look at that, we have the scope. Trend, well, it's not much trend because now it's 2 minutes. It already was recording because we are already a minute away. Yeah, there was not much change there. You can change the time, you can shorten or lengthen the time, restart the trend. And this meter mode, can we do something here? Yeah, peak holds, relatives, yeah, fine. I was looking for this. Can we do here something? Single shot. Glitch capture. The time base we can change faster. Ah, pretty cool. Pretty cool. And back to the default. Okay, that works. What about the DC voltage? That only goes to 3 volts. So let me put 1. Now let me put 200 millivolts. 200 millivolts. Yes, it does that. And then what if I put a trend and I go up a little bit? 300 millivolts, look at that. And now we are in the, I think it's 30,000 count, so it will switch over. And we can see the trend go up. It's pretty close. Look at this. Nothing wrong with that. Ooh, look at that, 3 volts. And the trend drops. Let's do resistance. Ohms measurements, I can do that here too. 20 ohms. Buff, yes. And what else can we do here? The trend. And usually the 1K is spot on, but I didn't zero it by the way, so I can do that. Wow. Look at that, that is 1K I would say. Let's do that with the DMM check plus with my 1% resistors. 100K, it should be, yep. 10K. 1K was spot on. Here also. 100 ohms. Wow. And let me do capacitance, that is possible. Yep. And 1. Here also works. Continuity. No, automatically does that also in diode mode. Open close. It seems very fast. Current. Oh, I need to use another one. It says this one. I have current here. DC on. I should have here 1 milliamp. And that is 1 milliamp. I can do the same in AC. Yeah, 1 milliamp AC, but it is not detecting the frequency correct. Let's play a little bit with the component test. I just get a resistor, I just get a random one, and then it's sort of making a circle. Get that same resistor. Now I get a diode. Look at that. The other way around. Different frequency, it responds different. Cool. Wow, if these meters work, it is an excellent piece of work. I like the little scope inside, and now you can change the meters. And that component tester is a little bit like a curved range, I think it's called. I don't know how to use it, but it looks very impressive. Well, after the cleaning they look a lot better, but it is not a mechanical problem, so I need to dive deeper into it. But I like the meters, they look pretty cool. Thank you for watching, and hope to see you next time.